Okay, we're on section 5.1, example 2, and this is the one with the true-false exam. A section of an exam contains 4 true-false questions. A completed exam paper is selected at random, and the 4 answers are recorded. Round your answers to 4 decimal places if necessary. First part of this says, assuming the outcomes to be equally likely, find the probability that all the answers are the same. And what we need to do this is we need to know first how many combinations altogether there could be if there's 4 true-false questions. And then the second thing we need to answer is the question that asks us here. We need to know how many of those combinations have all the answers the same. So to answer the first part of that, to get the total number of possible outcomes, it's the number of possible outcomes for each trial. And since it's a true-false, there are 2 possible outcomes for each question. Each one could be either true or false. And then that is raised to the number of trials. In this case, each of the 4 questions is considered a trial. So 2 raised to the 4th power is 16. The way you would do that on the calculator is the 2. And then this button here, and then whatever you're wanting to raise that number to. In this case, it's 4. So 2 raised to the 4th power is 16. So that's how you'd get that answer in your calculator. Then in terms of coming up with what all of those 16 combinations are, you're going to need to write all those out, and I've made a table here just to make it a little easier to follow. So what I have here are the 16 different combinations. So once you know how many different combinations you are, you're going to want to number your paper 1 through 16, or whatever number of combinations you have for your question. And then this is where the true falses. So for combination number 1, it's going to end up being true, 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 and I'm going to make this font a little bit bigger so it's easier for you to see. Okay, so we've got all trues for the first one. Then if we were going to just come up with the next one, it would sort of be trial and error, and it'd be not very easy to figure out what all the different combinations are and make sure you're not repeating any. So I've got a systematic way to do it. We're going to fill in all the possible answers for question 1 first. So whatever you got for the total number of combinations, in this case 16, divide that by 2 and fill in all of your answers with that. Up through number 8, and then switch over to false. Okay, so now whatever number you used for question 1, in this case it was 8, divide that in 2 again, and fill in question 2 with that many trues. So now I'm going to do 4 trues in a row, 1, 2, 3, 4, and then I'm going to switch to false. False, 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 true, 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 false, 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 false. Okay, and then same thing again. We're going to take 4 divided by 2 and we get 2. So true, 2 trues followed by 2 falses, and then continue till you're all the way through. And your last one, now divide 2 in half again, and we get 1. So this one we're just going to be alternating true, false, 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 true, false. Okay, so now we have all of our different combinations. Combination number 1 is true, 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 true. combination number 2 is true, 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 false. The first part of this question asked what is the probability that all of the answers are the same. So we want to know how many of these combinations that would be true for, and then we're going to divide that by the total number of combinations to get the probability. So for them all to be the same, they either need to be all true here or all false here. So that's 2 out of 16. And so 2 divided by 16 is the probability that we're looking for. And so the probability that all the answers are the same is 0.125. The thing with probability that you need to remember, especially for this section, but even going forward, the number that you get for an answer that's asking for a probability always has to be a number between 0 and 1, which means it's going to be 0 point something. If you get a negative, it's wrong. If you get a number besides a 0 in the ones place here before the decimal point, then it's also wrong. Usually if you get a number that's greater than 1, it means that you did this backwards. So if I had done 16 divided by 2, this is not working, 16 divided by 2. So why am I not able to type in 16? 16 divided by 2, I would have gotten 8. And that can't be a correct answer because that's a whole number greater than 1. So instead, it was 2 divided by 16 to get the correct answer of 0.125.